Hey folks, Eric Wooldridge here, the Additive Guru channel, and today we are going to take a look at how to use Fusion to create DXF files for plasma cutting applications. So it works pretty straightforward. The first thing that you're going to do is you're going to open up your Fusion, and one of the things that I'm going to do right off the bat is because a lot of conventional plasma cutter systems, especially in the welding fabrication side, they work off the American customary unit system, and so we need to make sure our settings are set to that first. So I'm going to go to document setting and change it from units to inches. There we go, and OK. Now the next thing we have to do is actually sketch out. Now what we're actually going for, just in case you're not familiar with the process, is a lot of times we can actually take a plasma cutter and use it to cut out flat shapes. So for example, if we're doing some kind of like strut or maybe some kind of support for an application, something that's 2D and has a lot of features to it, plasma cutters can take a sheet of metal and cut out this shape so the part falls out. So it's pretty standard equipment for a lot of machine shops, fabricators, and those kind of things. And it works off a 2D shape. So in Fusion, we normally go to 3D, but in this case, we'll be able to stay with a 2D application. So here we have an image of a plasma cutter off Google. Now you don't have to, it's not limited to just plasma cutters. This actually could be any kind of CNC application. It could be a router, it could be cutting out of wood, any kind of process where they've got some kind of tool that goes in the X and Y direction, this way and that way, and is using a tool to either cut a part out or cut it out with plasma cutter tool itself. And it's an automated process, and the parts are just often left in the piece to fall down below in the case of this plasma cutter, or they fall out when you remove the main sheet. But you can see in the image right here all these different parts that are cut out in the process. Then of course you can watch some YouTube videos on this as well. So how do we get to the programming of this? Well, we're not going to worry too much about the programming of the system as we are going to worry about the file that it's working from to actually make all these pattern cuts. So we're interested in the pattern more so than anything else. So let's take a look. So back into Fusion, it escaped there, back into Fusion, and here we are in a new Fusion file. I have set the units to inch, and the first thing I'm going to do is create a sketch, and I'm going to choose, make sure I'm very selective in choosing that I'm in the top view, and this plane right here. The X and Y coordinate system plane is the easiest to work with for this process. If you choose another plane system, you're going to have to orient it in a different way, which is more confusing. So when you start your sketch, make sure that you are in the top view. You can click on the top button there, and that you're choosing the flat plane at that point in time. Now let's just say, for example, we're going to do a very simple creation. We're going to make some kind of rectangular part, and it's going to have two holes in it, and that's all we're after. We'll say that the part is going to be, we'll make it 12 inches one way, 8 inches another way, and we'll make the holes diameter, we'll just go with a good old-fashioned 2 inches on each of those, and we'll place them with some inch dimensions here in a second. So that's the shape I'm after, 12 by 8 with some holes in it, and I can make that pretty quickly with Fusion. I can use my rectangle tool, I can also use my regular line tool, either one, and just draw a rectangle. We're going to go 12, enter. We're going to go down 8, enter, across 12, enter, and then of course a line to close them up. Now, I believe I've made a mistake. You see how there's a little bit of extra here, and see how this extra line, it looks like it created an extra line at the very beginning, and you got to watch out for that with Fusion. It does that sometimes. So I delete that line out and line it back up so it's perpendicular. Always be careful that you don't click too fast and you pay attention to, sometimes Fusion has a tendency to make those little extra ghost lines, and that can get you in trouble later. So there's that feature. Here's some two holes. We'll just assume they're about right there and there. And I will apply dimension tool to say it's going to be 2, and dimension is going to be 2, and then I will use a dimension from here to locate a certain distance. We'll say 4 is fine. We'll put in the right center, in the dead center, 4 over here, and then we'll just make it, I don't know, what do we got here? Let's go 3 from the edge and 3 from the edge. So I've used my dimension tools to create this nice outline that you see. And nothing special, I haven't done any tools, you know, I have dimensioned to the right size, but that's all I've created. At this point in time, I'm going to hit Finish Sketch. Now, normally what we would do in Fusion if we're going to create a 3D object is we go hit Extrude, but we're not going to do that in this case. No, all we're actually interested in is this sketch. And you'll notice that right over here is that sketch. It's still even highlighted. Sometimes it's closed, you can bring it back up, and sometimes it's actually turned off with the eyeball slash there, and I can unslash it. Either case, you need to be able to see the sketch, and you right click on it and you say Save as DXF. Now, as far as file naming, that is up to your class instructions or your quiz instructions, but you basically have to name the file as a DXF file, which can be just about anything. So I will actually hit save there, saves DXF, it pulls it up into a folder I want to put it into, and we'll say CNC example 1. Again, if you're given any instructions on assignments, make sure you follow those in terms of naming. I hit save, and my DXF file was created relative to this shape. I do want you to note, see this little icon right here? That is your icon for what we consider the origin, the X, Y, and Z point of 0, 0, 0. And it's going to matter where my object is in relation to that, especially when it comes time to do some cutting. All right. So anyway, the file's created. Let me pull it up and let me load it into a typical AutoCAD program. Now, you don't actually have to always use AutoCAD for stuff like this. This can actually work with a variety of different CAD softwares that can open DXF files, but AutoCAD is something that we typically have access to since we already have access to Fusion. So, we'll go fire it up. And I'm actually going to use an older version of AutoCAD just to show how simple and straightforward it is. Alright, looking for my file. I do notice that I have to set it to DXF so that you can see it. There it is. Because the DWG is a typical AutoCAD type file. DXFs are there. And we see it there. We hit open. And we see we're in AutoCAD here. A lot of your same tools apply in AutoCAD as they do in Fusion. For example, you roll the mouse forward and back. You get the zoom in, zoom out. You push down and hold the mouse, you get the pan. But I want you to look at something very, very important. Notice that the object is relatively in the exact same place the X and Y 00 was on the previous one. And that matters to us because of the CNC. I want you to also notice that when I click on the object, notice how it all highlights. You want that because the CNC system will not like anything that's a broken line or discontinuous. It has to be continuous all the time, and your circle and your object there are good. And one of the things that we are going to want to do is place this object right where the 00 is, because when a plasma cutter typically kicks off, it considers, if you go and buy a sheet of steel to cut from, it considers this point right here the 0, 0 point. So obviously you can't start cutting your object right on the edge. You have to give yourself a little space from the edge for it to have enough clearance to cut from. So you'll have a burnout if you try to cut right on the edge. So we typically recommend using about a ½ inch from the actual sides to place your object. So with that in mind, I have to figure out how to get my object here within a ½ inch of that, and that's actually done really easily. You just click and click around the object to select. You can tell it's selected by seeing the grips and everything, and you right click and you say move. Now it's going to ask you where you want to move it from, what point, and you just simply click on the corner, and then you're just going to type in 0, 0, which tells it to move itself at that corner to the 0, 0 point. And there it is. I'm panning down to see it. See how it's right there? And then my next option, of course, is to actually get it offset, because we don't want it to be on that corner. So I'll select it again, right click, and I will say move this same corner, and we can just type this value in. We can say 0.5, 0.5, enter, and it is now shifted from the offset, or from the origin, a ½ inch to the right and a ½ inch up. This is great because now, from its current location, it is the perfect place for me to work from. What the software will assume is that the plate of steel sits right here, and my object fits right within it. Obviously, a person needs to be able to buy a piece of steel that's bigger than the object they're cutting, but we'll assume that you can find the steel size, and these steel sheets can come anywhere between 4 to 8 feet in terms of length and width, maybe even longer than that. But for our 8 by 12, we could easily get by with a 14-inch and also a 10-inch sheet of steel and be just fine. So really our object is essentially ready to go. All we have to do now is save the file again as a DXF file, and that could just be another matter of saying file here at the top like any other program, file save as. Make sure that it is set to the DXF version, which I typically go way on back in terms of AutoCAD, DXF older, into 2000 version, and then just name it whatever you want to. Make sure it says the DXF, hit save, you may call it 1B or something, save, and it is now saved as a DXF file. And you look at this scenario, you may say, well, you know what, that's pretty easy. Why couldn't we done all that in Fusion? And the answer is you absolutely can. You just have to make sure that you're on top of your game. But let's first have you do this. Let's go ahead and have you pause the video and kind of recreate what I've done so far. You can open it up in AutoCAD and actually do it that way if you want to, and just give it a shot. If you don't have AutoCAD, then you can just skip this part and come back and watch the rest of the video, and I'll take care of it there. Okay? Alright, so let's just say we don't have AutoCAD as an option, so we need to take care of all of it in Fusion. That's no problem. We can actually do it here just the same. So I will go back into my creation. I can actually start from scratch, or I can go back to right click and be inside my Edit Sketch. And my objective will be to move this thing a ½ inch from the origin. So first thing I'm going to do is see if I can't just kind of drag it up in space, and I totally can. And then I'm going to use my dimension tool to click here, and at least I think I am. No, it's not going to let me. So whenever you can't get it to actually let you draw a dimension, you can create your own by going to draw a circle and click on the construction line and click it to the origin and just draw it there. And then now you can go dimension here to here, set it, and let's just see if we go 0.5, pulls it down. Again, dimension here to here, and 0.5 pulls it across. At that point in time, I can actually delete off my construction line. It may not have shown up anyway, but we'll see later on. And that has now located my object that is to be cut 0.5 units or 0.5 inches from the origin to the right and up, which gives me plenty of clearance all the way around for cutting. Okay. So we're going to hit Finish Sketch again, and this time I'm going to right click on Sketch here, say Save as DXF, and I'm going to call it Example 1C. And let's just see how that looks in the AutoCAD, see if it lines up where it's supposed to. So I'll just open it here, and sure enough, it's the exact same place. You click on it, the whole thing is continuous. You click on that, it's all good. We can check it further by deleting stuff, and if everything deletes out, we know it's good too. So that's one way you can do the entire process in Fusion instead of having to integrate into AutoCAD. We've done it both ways, so we want to show both processes. The most efficient though is to do it all in Fusion and make sure you're offset from the origin at 0.5 from to the right and to the left. Now if you're switching to units into metric, that's not a big deal. You can easily do that before you export, and it should take care of itself. But that's the process, and the best part about Fusion is, of course, you can always go back and edit in additional features. Let's say you realize that you need some kind of a slotted feature right here. That's no problem. Finish Sketch, and then you would export again as DXF as an updated file name. And save, and we'll check it in the AutoCAD to make sure that it worked. And there we go. Okay, so there you go. There's the primary understanding about CNC setting these files up for plasma cutters, CNC routers, whatever the case may be. Remember the basic rules. 1, it has to be a 2D sketch. 2, it has to be continuous. The output has to be continuous, which if you DXF out of the sketch, it will be continuous. And of course, you have to give yourself some space from the origin so that it doesn't try to cut along right on the edge of the part. Now don't get me wrong, we have gone tighter values than ½ inch. We have pulled them down into quarters, but generally with bigger objects, because of that variation and things not being perfectly aligned, we recommend ½ inch to get started. Now other features like rounding things off, you can still do that as well. you can go to your sketch, right click and edit it here, and you can do things like a fillet. Click on that corner, maybe this corner, set the values to be whatever you want them to be. We'll say 1 inch, and looks like it's okay there, that's fine. And then we can also do other things too, that's fine. Alright, so there's my radius, and I can of course do more stuff than that, but we'll check it one more time. Make the change, right click, save as DXF, keep renaming it to something else, and I'll check it in AutoCAD. And there we go. You'll notice once again it is continuous. Again, any kind of plasma cut or CNC cut, the line that you're following has to be continuous, no uncontinuous things. And another thing that we often check is to make sure that it has only one layer, which this one does. And Fusion's going to pop it out that way. Alright, so anyway, I want you to pause the video and go back and just create it all from scratch, perhaps in Fusion, and not need the AutoCAD step out, especially if you don't have AutoCAD, and that way you can create the DXF and have it ready to go. Alright, go ahead and do that now, please. Okay, so anyway, there's your main rules to remember. Again, remember, things have to be continuous, things have to be offset from the origin. Recommend 0.5 to the right, 0.5 up. And you make sure there's nothing. You can always double check some things here and there as you go along, but make sure your objects do close and they highlight, so that way you know when you DXF out, the line will be continuous. Alright, thanks for watching. We'll see you.